video is on Unit 2, Chapter 6, Lesson number 3 on writing quadratics from zeros. In this lesson, we are going to take the roots or solutions and work backwards to the actual quadratic that would have resulted in those solutions. So in this bullet, this first bullet, under writing quadratics from zeros, you will use the roots or zeros, which are the solutions, to work backwards to find the original quadratic equation, which is what I just said. Remember that roots or zeros are what x is equal to. So in chapter 5, those were what we were putting inside the braces. So the solutions to the quadratics is what we're going to start with this time, and we're going to work our way backwards to the quadratic. Factors are the binomials that multiply to create the quadratic equation. And then the one that's really important here is that irrational roots and complex roots come in pairs. So if you think about that, anytime you use the quadratic formula and you have an irrational answer, it might have been something like 2 plus or minus 3 radical 5. That might have been an answer. But you had both a positive and a negative, so they come in pairs. Same thing with complex solutions. I could easily stick an I with that 3, and those are two complex solutions, so they come in pairs. So that's the one that a lot of students will have a tendency to forget, is that your irrational roots and your complex roots come in pairs. So let's look at an example here, or let's look at these steps. So here are the steps to working backwards. Number 1 says to set x equal to each root. Number 2 says if the root is a fraction, multiply the equation by the denominator. I'm going to put a big star next to number 2 because that's another step that a lot of students will forget to do. Thirdly, use opposite operations to get a 0 on one side. These are your factors, and then we're going to multiply the factors together and then write in function notation. So number 1 here in the directions, it says the roots of a quadratic function are given. Write an equation that could represent the quadratic. So again, these would have been our solutions. We have a real rational answer of 5 and negative 8. So step number 1 is going to tell us to take x and set it equal to each root. Now, if we had fractions, which we don't, we would want to multiply that by the denominator. The third step is to use your opposite operations to get a 0. So I'm going to minus the 5 to get the 0. Now the left side, the x and the 5 are not like terms, so it's just going to come down as x minus 5. Same thing on x equals negative 8, opposite operations. We're going to add 8 to both sides, and we get x plus 8 is equal to 0. The next step is to take these two, what are called factors. So the x minus 5 and the x plus 8 are the two factors that will create the quadratic. We're going to use both the x minus 5 and the x plus 8 to multiply them together to write this quadratic. So you're going to get a lot of practice with distributive property. X times x is x squared. X times 8 is 8x. Negative 5 times x is negative 5x, and then negative 5 times positive 8 is a negative 40. Now, I've said it before, I'll say it again. These two middle terms are going to combine, and we get x squared. Negative 8x minus 5x is a positive 3x, so plus 3x, and bring down the minus 40. Now, at this point, all I need for you to do is stick an f of x in front, and there is the quadratic. And what I would like to do is I would like to show you what just happened. I'm going to go to y equal, and I'm going to put in that x squared plus 3x minus 40. And I'm going to show you that the two solutions here are 1, 2, 3, 4, 5, and -1, -2, -3, -4, -5, -6, -7, -8. So -8 and +5 are the solutions to this quadratic, which is what we were supposed to get. -8 and 5 are the two solutions that we started with, and we worked our way backwards to the quadratic. Example number 2 gives us 1/2 and 4/5 as the two solutions. Again, the steps are x equals the number. X equals the number. Now, again, you have fractions on this one. So make sure you don't skip step number 2. In each of the two equations, we want to multiply by the denominator. So x equals 1/2. The denominator is a 2. So I'm going to multiply the right side by a 2, and I'm going to multiply the left side by a 2. On the right side, the reason why we choose the denominator is because the 2's will cancel each other out, and you're going to be left with the numerator. 2 times x on the left is just 2x, and then use your opposite operations to get your 0. Same process for x equals 4/5. It is a fraction. We need to multiply on both sides by the 5, and that's going to cancel those out, and I'm left with just that 4 on the right side, and 5 times x is 5x. Opposite operations, subtract the 4, and we get 5x minus 4 equals 0. Again, we're going to take these two factors and we're going to multiply them together. So 2x minus 1 times 5x minus 4. Using the distributive property, take the 2x times both and the -1 times both. So 2x times 5x is 10x squared. 2x times a -4 is a -8x. -1 times 5x is a -5x. And -1 times -4 is a +4. Combine those two middle terms, and you get 10x squared minus, -8 minus 5 is going to be -13x. Bring down the +4, stick an f of x out front, and you've got your equation. Again, y'all, you should be writing an equation. In past years, I have had students leave it 10x squared minus 13x plus 4 in an answer blank. And that's not okay. That is not an equation. That is what we call an expression. So you need to have an f of x on it. And at the very least, a 0 equals 0. Because again, you are creating that equation. All right, let's look at another example. Let's look at number 4. Number 4 says the square root of 2. So this is an irrational solution. Irrational solutions come in pairs. One is a +2 and one is a, positive radical 2. One is a negative radical 2. You cannot count on me to put both the positive and the negative there. You can't count on EOC people or ACT people to put both solutions. You have to know that it's there. So let's take and set x equal to the positive radical 2, x equal to the negative radical 2. This is going to look weird as we go throughout this process. Just bear with me. I'm going to use my opposite operations and subtract the radical 2 from both sides. And we get x minus radical 2 equals 0. On this other one, I'm going to add the radical 2. And we get x plus radical 2 for this one. Now, we're going to multiply x minus radical 2 times x plus radical 2. Same process. distribute, 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 distribute. X times X is X squared. X times a positive radical 2. Again, this is going to look a little weird. It's going to be a positive X times radical 2. And then negative radical 2 times X is going to be a negative X radical 2. Now this last one, negative radical 2 times a positive radical 2. I'm going to pull up my calculator for just a second. I have a negative square root of 2 times a square root of 2. It should be negative 2. And anytime you have a radical times itself, it's just going to give you the number that's underneath. So the last term is a negative 2. Now, these two middle terms, when you guys have these irrational solutions, and the same thing's going to happen with complex, these two middle terms are going to subtract out. They cancel each other out, and we're left with x squared minus 2. Put an f of x out front, and there's your quadratic. Number 5, very similar. These are complex solutions. Also come in pairs. So again, it's a positive and a negative 4i. So x equals a positive 4i and x equals negative 4i. Opposite operations, minus 4i. That goes away, and I have x minus 4i equals 0. On the next one, we're going to add the 4i, and we get x plus 4i. And we're going to take our x minus 4i and multiply by the x plus 4i. Same process. X times x is x squared. X times 4i is a positive 4xi. Negative 4i times x is a negative 4xi. And then I need a negative 4i times a positive 4i. And I'm going to go back to the calculator, and I'm going to do negative 4i times 4i. And we get a positive 16. So plus 16. These two middle terms, just like I said a second ago, they're always going to cancel each other out. And what we have left is x squared plus 16. Put an f of x out front, and you've got it. I'm going to go through example number 7 real quick. And we'll talk more about these in class. This one is a little more complicated. X equals 3 minus 2i, keeping in mind that it is complex, it comes in pairs. X equals 3 plus 2i. So we're going to have to, I'm going to bring everything to the left. So minus the 3 and add the 2i. And I know that that seems weird that I would go through all of that, but I prefer to have my x turn positive. And then on the other one, again, same thing. We're going to do x minus 3 equals the 2i and then subtract the 2i. All I've done is the same thing that I've been doing, and I am getting everything on the left side. Now, we've got x minus 3 plus 2i that needs to be multiplied by x minus 3 minus 2i. There's a lot more multiplication that's going to go on here. X times x is x squared. X times negative 3 is negative 3x. And then x times negative 2i, this one's going to look funky, but it's going to go away here in just a minute, is a negative 2xi. Now for the next term. Let me erase these marks here just so that it's a little less confusing for you. All right, so next we're going to do the -3. So -3 times x is -3x. -3 times -3 is a positive 9. -3 times -2i is a positive 6i. And I'm going to do that one more time. And the last one is that 2i. 2i times x, I'm coming down to the next row, is a positive 2xi. 2i times -3 is -6i. And then 2i times a -2i, we're going to do in the calculator. 2i times -2i gives me a positive 4. So plus 4. Notice that you have a -2xi and a positive 2xi that are the same, so they're going to go away. You have a positive 6i and a -6i that are also going to go away. Every single time you do one of these, all of your i's should disappear. Now I can combine my like terms. I have x squared, -3x minus 3x is -6x, and then plus 9 plus 4 is a plus 13. Stick an f of x out front, and there is your equation. So number 6 and number 7, I'm not going to lie, they are a lot more drawn out. There's a lot more multiplication that needs to be done. But overall, this lesson is not going to be too complicated. It's just a lot of multiplying. So those are your notes on lesson number 3, writing quadratics from zeros.